Good morning. This is Pat O'Connell. I'm calling to order a special open meeting of the New Mexico Public Regulation Commission. This is the third in a series of grid modernization, integrated distribution planning, and cost effectiveness evaluation in a series that's leading up towards potential rulemaking on implementation of the grid modernization statute. So could you call roll, Mr. Cameron?
Commissioner Ellison,
Present.
Commissioner O'Connell,
Here.
Commissioner Aguilar.
Present.
All commissioners are here and you have a quorum, Mr. Chair.
Thank you. So next, we'll stand for Pledge of Allegiance and the state pledge. So we have an agenda posted for this meeting. Does any commissioner have a revision to the agenda, or should we proceed with the agenda as posted?
I don't have any changes. I have no suggested revisions. Thank you.
Okay, so seeing no changes to the agenda, we will proceed. This is an informal workshop. Again, it's one in a series that's been led by Commissioner Ellison. So at this point, I will turn the workshop over to him.
Thank you, Mr. Chair. It's our pleasure to convene this informal workshop on grid modernization and in this case, cost evaluation, cost benefit analysis. We are working up towards a potential rulemaking. The discussion that we're having today on cost effectiveness, cost benefit analysis is solely for the purposes of the rulemaking. The commission does want to understand best practices around cost effectiveness evaluation, understand what other jurisdictions are doing in this regard, and solicit utility and other stakeholder and public input towards this rulemaking. Any pending proceedings on grid modernization will not be discussed here. I've asked Mr. Scott Cameron, our chief counsel, to be the bad cop and interrupt anyone should we stray into the pending case, which I very much doubt that we will. I'd like to open the floor to my fellow commissioners and ask if you'd like to make any opening remarks.
Yeah, I'll just say good morning and welcome to all that are here, including our guest from E3, and looking forward to the discussion. Thank you.
Likewise, I'll be short. Welcome, everybody. And, I think this is definitely an important topic to discuss and, here to learn. So thank you.
Great. And certainly do appreciate everyone's attendance today. Nice to see such a big EPE contingent and nice to see everyone here. I think we can go ahead and start off with our presentation by Mr. Snuller Price from E3, which stands for Energy and Environmental Economics, a large consultancy. Let me just say a few words of introduction for Mr. Price. He joined E3 in 1993 And he has led their distributed energy resources and distribution planning practice areas. He's worked with state and state governments, the federal government and utilities on the clean energy transition, has developed cost effectiveness analyses for distributed energy resource programs. His area of expertise includes evaluating grid modernization investments and non-wires alternatives to distribution planning. He co-authored a paper in 2012 in Science entitled "The Technology Path to Deep Greenhouse Gas Emission Cuts by 2050, the Pivotal Role of Electricity." He has a master's degree in engineering economics systems from Stanford and a BS in engineering, a BA in economics from Swarthmore College. It's my pleasure to have Mr. Price here with us today. So thank you.
Thank you, Commissioner. And Commissioners, I'm really happy to be in New Mexico. Good morning, everyone. Just logistically, if I stand here, this is the microphone. Maybe I'll move it here, is that? And then hopefully folks, because I know there's some folks on the web, hopefully they can see me from the camera here. And then I brought some slides, actually quite a few slides. I know some people got up quite early to be here. So appreciate that and the drive this morning. My part of the agenda is about 90 minutes or so, and I've got time for questions. There's sort of like 4 sections I wanted to do. So I think if it's okay with you all, Commissioners, I would do a section and then ask if there are questions from you all, and then from our audience, utilities in the audience, and then we can kind of, that way, if you have a question on section 1, you don't have to wait 90 minutes to ask. And we should hopefully have time at the end. Although I do have a lot of PowerPoint, and I'm going to run through quick and we try to keep everybody awake and focused. So with that, can we put the slide deck up on the screens? Hopefully everybody will be able to see it. People on this side of the room, you have a screen you can see? Okay.
The background here. Apologize for the technical difficulties here in the presentation.
It's quite all right.
We good?
We just need to share screen with the presentation.
Excuse me, commissioners. I don't believe I was sent that slide deck.
Yes. You were not, did you say, Patrick?
Yes, Commissioner, I did not receive that. My apologies.
I did send that to you and Jennifer this morning, so it should be in your email.
Yes, my apologies. Let me pull that up, Commissioner.
Voila. Great. Thank you. And I assume everybody on the web can see it and we're good. Great. Again, pleasure to be here. My name is Snoop Price. The topic I'm going to talk to today is benefit cost analysis for grid modernization investments. My team and I did a jurisdictional survey around benefit cost analysis around the country, supported by the Berkeley Lab with support from the US DOE. So my funding to be here is really our federal tax dollars at work. And it's really been a pleasure for me to work with the lab because it means that I get to travel and go to places around the country who are working on particular topics. And so it's really my job today to kind of report back after having combed through a lot of proceedings, a lot of testimony, a lot of best practices, the DOE materials, et cetera, and sort of walk through benefit cost analysis for grid modernization investments. So hopefully that's why you all came. If we go to the next slide, should have the agenda. So really there are 4 sections that I wanted to talk through, just an introduction. I think it's useful for me to talk out around or share sort of what I've been looking at from the New Mexico materials. I'm not going to tell you all what's happening in New Mexico. You all are the experts at that, but I think it's useful for me to just sort of say, this is what I was looking at. And then talk a little bit about grid modernization in other states. The second section is developing a framework for benefit cost analysis, sort of what are the big shaping assumptions when you go about setting up to do a benefit cost analysis, least cost best fit versus benefit cost analysis. What are states doing there? The third section is a survey of 10 different states that did benefit cost analysis for grid modernization. And we're going to talk about what they did and what they found. And then the last section is really on methods. I want to, when you look at the testimony, when you look at filings from utilities, a lot of times you get sort of the top level numbers. Here's the total benefits. Here's the total cost. And so in this method section, I'm going to try to go a little bit under the hood from examples that I've done in the past around how do we get to those benefits? How do we monetize those? How do we deal with those like in the details, components of it that build up through the framework to give us an overall benefit cost analysis. So that's the agenda. If we go to the next slide. Next slide, sorry. I wanted to start here. It's just 2 maps from studies of grid modernization activities across the country. And the first reason I wanted to show it is because obviously my job is to look out across states that are doing work on grid modernization and making investment decisions around grid mod. And this gives a perspective of the country. There's many states, many proceedings where states are looking at that our team has been kind of going through. The other thing that I wanted to point out is that the 2020 grid modernization activities shows no activities in New Mexico, and I happen to know that is false. I think there were very few, and that if we look at the 2024 study, it's gone from some to a lot here in New Mexico because of the Grid Modernization Act and other activities here in New Mexico. And what I'm really presenting and reporting out on is some of the information that has come out of these studies around the country. We go to the next slide. So what have I been looking at? So I've been looking at the House Bill 233, and I've got some screenshots from that. Been looking at the Energy Transition Act, which I think has a lot of implications for what's coming in New Mexico's grid. Some of the other bills, it's very helpful grid modernization website. And just sort of looking through that. I'm no expert on any of these particular things, but just sharing out, there does seem to be quite a bit of activity going. That's all I'm going to say to that. We go to the next slide. So the Grid Modernization Act, and I've seen this list in a couple different formats. And I wanted to just, and I went through and added the bolds so that it's a little bit more readable. My first impression with your Grid Modernization Act is that there's a lot in here compared to a lot of the filings we've seen around the country. This is a long, pretty long list. I thought in particular, there was some interesting things in here in particular that feel a little bit more maybe updated than, quite frankly, than a lot of states. One is distribution system hardening projects, with the exception of undergrounding. So I'm going to talk a little bit today later about resiliency and resiliency analysis and how states are dealing with that. I think that, this spans investments on the grid side, on planning, on customer facing technologies. And we're going to walk through sort of how we look at benefit cost analysis for all those different types of technologies. The other thing that I would say about this is that these are really technologies and not so much like the goals, like what you're trying to achieve by investing in those. And that will come up when we start to talk about benefit cost analysis, because the benefit side of the equation is like the value of what you're achieving with it. And so I think we'll get to that piece as well. So if we go to the next slide. I highlighted and zoomed in on this part of the Grid Modernization Act and bolded out a few lines that was really influential in sort of framing everything that I put together for today. So it says, Commission shall review the reasonableness of a proposed grid modernization project and maintain reasonable operations, maintenance, and ratepayer costs. And so to me, what that means is reasonable. So how do we know what reasonable is? And the goal of the presentation then is to talk about sort of how various states address reasonableness and provide examples. And I'll tell you that the sort of industry standard for looking at reasonableness is benefit cost analysis. And that is why I'm so focused on benefit cost analysis in there. Reasonable means weighing the costs with the benefits to make sure they are reasonable. So that's sort of the guiding line for how I've put this together. So if we go to the next slide. So the other thing that I wanted to point out is that the grid is changing quite rapidly, or planned to change quite rapidly. On the left side of this picture, I have planned renewable capacity for New Mexico, or the IOUs in New Mexico. And under the Energy Transition Act, and you all know this, it's a huge amount of renewables. But I wanted to highlight one thing in particular for a distributed resource, distribution engineering person like me, which is it's got this big band of storage, right? Because we got a lot of intermittent renewable generation. We need to do balancing, resource adequacy. So that storage could be bulk system storage. But when I look at it from a distributed person, that could also be load flexibility. And what that means to me is as we go out, I mean, this is 2040, we'll all, this will be quite a ways down the road, right? But it looks like we're going into a world where flexibility of loads, if it can offset storage, which is quite expensive, is kind of coming in towards some value. So how do we value that? We'll get to that. But to me, just from the surface of it, it looks like flexible loads are really potentially interesting. The other thing I wanted to point out is on the right-hand side, the electrification. And the electric vehicles in particular are an orange bar on the right coming. Again, this is way down the road, 2042. That is a huge amount of potentially flexible load. And it's a huge amount of new load service for our distribution grids. So how are we going to manage that is a question that I think comes up when we're talking about distribution grid modernization. We've got the EVs coming. There's also a sliver of building electrification. It's not as scary a bar, but still it's another load that the distribution system has to be able to manage. All right, if we go to the next slide. So just one more detail. Our team has been looking at the EV wave coming. New Mexico is a clean car state, which is a consortium of states that are looking at a trajectory that would achieve 100% of new vehicle sales to be electric by 2035. This is a picture for 2032. What we did is we layered on recently, the Biden administration has a new CAFE standard, which affects all the states. So this chart shows New Mexico would be in the green clean car state and all those other states. And it's the percent adoption in 2032 of light duty sales. And it shows that across the country, we're going to a place of 50% or more in most states. New car sales will be electric by 2032, which is just around the corner for our electric distribution systems. I mean, that transformer is still new. If we buy it, it's not that far into the future, and that's driving a lot of the EVs that we saw on the prior chart. The other charts that I showed on here is not only is there a lot of federal policy driving electric vehicles, there's federal policy driving building electrification. So there's big incentives for heat pumps, there are tax credits. And so, really, regardless of the state policy, there's some federal drivers towards electrification in sort of this plan for decarbonization. And, New Mexico will be on the, I don't know if you want to say the receiving end or the participating end, but it's, either way, in that soup of connecting increasing amount of electric load. So if we go to I think that might be, is that the last slide in this section? Yeah, you can go back to the title slide for a sec. So that was just my quick introduction of sort of what I'm trying to do, what we see coming. And I wanted to just pause for questions, also make sure our tech is working. But commissioners, any questions so far? Hopefully the framing helps under what we're doing.
Yeah, I don't have any questions. I think I'm with you. So thank you.
Okay, thank you.
There is a question from someone on Zoom.
Hi, this is Arthur O'Donnell. Can you hear me?
Yes.
Mr. Price, on slide 8, you're showing the bars in terms of kind of expected impacts for the DER and grid modernization, but the chart is has the bars going across both negative and positive, and I'm wondering what that represents.
Oh, those, so we borrowed this chart from that reference that's linked, but my understanding of what that means is that's basically negative load behind the meter. BTM solar is behind the meter solar, so that's reducing loads. TOU rates through load shifting, reducing loads. And then on the other side of the ledger, electric vehicles and building electrification, increasing loads. Is
Okay,
that-
so storage isn't included in this because that would straddle the line, right?
Well, storage, the two charts are from different sources and disconnected. The one on the left is really a bulk system resource plan mix. And on the right hand, I've just focused on distributed energy resources. So like loads that are out that the distribution system needs to hold. So I think the vision and the IRP slides on the left is that it's bulk system grid storage for resiliency, or not for managing intermittent loads. And on the right side, DER, sorry, it's like alphabet soup, but the peak load distributed energy resources are on the right-hand side charts.
Okay, great. Thank you very much.
Yeah. And all I really wanted to say with this was we've got changes coming, a lot of new loads that we are not used to connecting, and a lot of potential for flexibility, particularly on EVs.
On that last slide, the CAFE standards, so this is projecting that sales of light duty vehicles in New Mexico will need to be 80% EVs in 2032.
Yes.
Is that correct?
That is correct. On the way to even higher levels of 100% by 2035.
And so federal statute is driving that, or?
There's two things that are going together. The Clean Car States is a coalition of states. So that is New Mexico's opted in to being a clean car state. I put the governor's announcement there in the link. So that is optional, but what is not optional is that the CAFE standard, even if you're not in a clean car state, has portfolio requirements for the car manufacturers to have very high levels of adoption in any case.
Would that be is this the 60% or 65% number national average?
Sorry, I'm getting close.
Yeah.
It's like 68%, something like that.
Okay, thank you.
Yeah. Okay, so I wanted to start with developing the BCA framework. So this is sort of the overall set of questions you need to think about before we dive into calculating any specific benefit or anything like that. So if we go to and I hope this isn't going to be too small, but we'll get there. So, okay, so how does the utility demonstrate that proposed grid modernization investments are reasonable for its customers? So what I thought might be useful to start with is a picture from the DOE framework guide, volume 4, that shows, well, customer needs. What do customers value? If it's reasonable for customers, what are we providing for them? And you can see in these circles, reliability and resilience, electrification, DER integration, the ability to connect my new electric vehicle, safety and operational efficiency are tantamount. We've got to keep a safe system. And then, of course, not on this customer needs is affordability. And so those are sort of the 4 areas that we're going to try to dig into more. How are we valuing reliability benefits? How are we valuing the electrification, ability to interconnect new load, safety, and other customer needs? And again, all framed around, is it a reasonable investment for customers? So if we go to the next slide. So the first place that most of these frameworks, and I've given 3 examples, these are all different publications on sort of a similar theme of how do you set up this analysis. They always start with keep customer top of mind. So affordability, service quality, those things that we were just looking at. Also access for either hosting capacity for solar or electric vehicle charging, equity, and the environment. So we're going to talk about each of those pieces. Universal themes across the different frameworks, starting with objectives of the process. So our objective is not to just buy the technology, whether it's smart switching, whether it's volt VAR optimization. The objective is really, or should be, around what the customers want. So is it reducing energy use? Is it providing better power quality, better reliability, some combination of all of the above? These frameworks, the other thing about it is that they're sort of like a pyramid. So they all start with a set of principles, which are pretty normal for a regulatory process, where, you know, these sort of fundamental things, what are we going to make sure we hold to? That's pretty high level. And then objectives, what are we trying to achieve? And then it starts to get real heady, especially in grid modernization, pretty fast. What's the capabilities of the different technologies to deliver on those objectives? There's different, you know, types of metering. There's different functionality that you can layer in. You know, how do we sort through those? And then finally, you know, which technology are we choosing at the end of the day? So they're kind of organized in a pyramid in terms of a framework, starting with like, what's our principles? What's our objective? And then kind of getting down farther and farther and farther until you're down into like technical specification of my like data backhaul and cybersecurity, you know, and really into the details of the parts you're ordering to accomplish the objective. So if you go to the next slide, starting with the principles. And I borrowed this, there's similar lists of principles. This one that I referenced here. And I tried to really, I don't want to read them all. I really tried to think of 3 buckets that I see when I look at these principles that I think are useful starting points. On the blue arrows, if I kind of blur the principles of all of those, really what it means is use forward-looking estimates of benefits. So what we're gonna save over the life of the investments that I'm making. Sounds pretty simple. Those like 5 or 6 things, that's pretty much what they say, forward-looking investments. On the right-hand side, in terms of the yellow ones, really, I think it gets to be responsive to stakeholders and their concerns. And stakeholders here mean state regulatory and policy goals, the utilities, and the customers. And then the third one in the green, which we'll be talking about a little bit later, is really grouping investments and how do we group investments that work together? Because some things are fundamental, kind of core investments, other things add features, they work together. And so it's useful when you're doing this, going down through your pyramid from objectives to have, you know, really all the things together grouped that you need to achieve those objectives. Makes your analysis much simpler. We could talk about principles for a long time, but I want to just kind of I'm going to keep going. So if we go to the next slide. So I touched on this before. Objectives drive investment decisions. And so objectives, something like, this is just examples here, service quality, affordability, greenhouse gas mitigation, all common examples. Move to a kind of targets and constraints. So service quality, what do we mean a little bit? Let's dig into that a little bit more. Maximize reliability and resilience. Okay, so what does that mean? Well, I have some metrics, SAIDI, SAIFI, those types of things. Maybe that's how I'm going to measure. And then that gets me to, okay, maybe I will do my grid hardening investments will help me with that. My fault location sensing devices will help me with that. Kind of working from, from left to right objectives to investment priorities. And, we saw this earlier in your Grid Modernization Act with the 12 items. It kind of lists a lot of the things you would put on the right-hand side of your, the things that you're buying, basically. And so one of the challenges, I feel like, could say that in New Mexico, is working backwards to the objective. Like, okay, why did we do that fault sensing and what have you? So, and obviously these objectives are not mutually exclusive. So you can try to achieve all of these and make improvements across all of these. So that's probably pretty self-evident. We go to the next slide. And I'm gonna, hopefully this pace is okay. I'm kind of trying to go relatively moving along because I know we have a lot of experts in the room, so please bear with me. And if all want me to go faster, I can too. So I borrowed this chart from the DOE guidebook for the foundational components versus applications. And I think this is a really interesting way to put a whole lot of capability and grid modernization investments onto one picture. And it's kind of built like a stack. So from the bottom, it's got the core. And then it kind of builds up more and more capability as you go up. The very bottom of the stack is physical grid infrastructure. So that's just, our wires, our substations, transformers. Without those, we do not have electric service, obviously. And that's actually the world where we're used to doing a lot of planning. We're used to effectively least cost, best fit, right? If we are gonna forecast an overload on our substation, then we find the least cost way to customers to add capacity, whether it's switching, new bank, what have you. So the core at the bottom is really around those things that you actually need to provide in order to hit your obligation to serve customers. It's a least cost best fit type of framework. I'm gonna make my investments. And then as we work up, we get more and more capability that are kind of in some sense enabling the features from the top. So communications, sensing and measurement, data, we're gonna end up with tons of data. How are we gonna manage that? There's some, in the light blue, there's some planning functions that use that data, power flow analysis, et cetera. There's the gray, or I guess gray, some different capabilities. And then on top of all of that are really more like what we're calling applications, what DOE calls applications in this, with really like hosting capacity, locational value analysis, markets, settlement. This is a whole kind of wish list and set of activities. And the reason I wanted to put this up here is that when you look at the actual filings of different states, they define what's core or not core differently. So some are, our smart meters are core. We're going to do that. California did that. Other states are, well, we don't need smart meters. We can read the meters just the way they are. So let's do analysis. Is it going to be worth it for us to invest in that technology? So if we go to the next slide, I wanted to kind of, this is, we'll come back to this one. If we go to the next, hopefully. And one more. Thank you. I wanted to just sort of talk about this idea of least cost. What do you use least cost best fit for? And what do you use more comprehensive benefit cost analysis for? So California, where I'm from, really has a lot of least cost best fit analysis. It's like, well, we're going to go ahead and do this. Let's do it in the best way. On the right-hand side, we have Massachusetts, which is like, really, if you want to do almost anything, you're going to do benefit cost analysis. We're not committed to making that investment. We're going to see if it's worth it to our customers. And there are states like all the way in between, just picking on New York, they do benefit cost analysis for their AMI, customer utility facing, both sides. They've standardized the BCA handbook that allows them to, do these grid modernization analyses in a sort of standardized way across the 5 utilities in New York. Minnesota, also a lot of benefit cost analysis. and so I guess my point is, you know, when you look at the details, each commission in each of these states has really sort of decided where they want to be along that spectrum. Now, sorry about this, but if we go back 2 slides. I use some terminology in there, and I really like this kind of division of grid modernization investments, because there's a whole set of utility facing investments and there's a whole set of customer facing investments that your customers will know about and participate in. And so it's just another way to bifurcate what you're doing. Utility and facing investments, of course, can provide and should provide customer benefits like less energy use through volt-var optimization or faster restoration times. Those are utility side investments that help benefit customers. Everything should benefit customers, but it's just useful to create that, division. If we go to the next slide, this is another publication and another framework that talks about when do you use least cost best fit, when do you use benefit cost analysis, and it's actually a third category, customer choice category, which is like self-supporting. So if a customer wants to make an investment on their own for their own benefit, then you don't have to pay for it. Then it's more of an interconnection, like maybe backup reliability or something like that, that's self-supporting. And under this framework, it's still pretty, there's got this policy and standards compliance bucket that goes to least cost best fit. I think that's what we would expect. If you have to do it, then let's do it in the least cost best fit way. There's another investment driver in this framework that's joint benefits, which really just means it's got a whole number of different stakeholders participating. It's very difficult to sort out. And so we're decided we're doing it. So there's a link there. You can dive into that some more. But I think this idea of least cost best fit versus benefit cost analysis is, not 100% consistent across all of the DOE legislation. And when we look at what states actually do, there's quite a range. So if we go to the next slide. Okay, we did that one. Okay, so now I wanted to switch gears a little bit and talk about, okay, so we were talking about this basket of benefits or basket of technology that we're investing in. What benefits do I get? And so usually the way this works is mapping through use cases. So for example, on this chart, we have AMI, Advanced Metering Infrastructure. Okay, so what benefits is it going to provide? Well, it depends on what are we going to use it to just read the meters? In which case, it's a meter reading that is the benefit. Are we using it for a platform for time of use rates where I can get some load shifting? That's a different use case. So all of these things sort of go through the technology, the use case, and then a mapping. There can be more benefits, and we're going to go into detail about all the different benefits typically looked at. But energy, greenhouse gas emissions, environment, reliability, these are not all necessarily benefits in our chart here that are a reduction in utility revenue requirement and customer costs. Some of them are benefits, for example, cleaner environment or better service reliability, which are not a part of your revenue requirement. They're a part of just what customers expect, servicing back to that customer needs. They want high reliability, they want a clean environment, et cetera. So if we go to the next slide. So this question always comes up about, okay, I'm going to do benefit cost analysis. I've got my technology, I've got my use case, I've mapped to benefits. What cost test am I going to use in order to stack up my benefits and my costs? And I always suggest that, people think there's a right cost test and a wrong cost test. And I don't think that's actually accurate. Each cost test just asks really a different question. So which question do you want to know the answer to is the what you're, where you come out on the terms of this sort of which cost test. And if you think about them, and just starting on the left, managing cost shift and affordability, that yellow ring, affordability is, what customers pay for in their rates. So the utility cost test. My understanding is utility cost test is used for energy efficiency programs in New Mexico. So, is the total level of bills higher or lower because of my efficiency program? That's what that's telling us. That's that question. The other piece of this is ratepayer impact measure or rates. Okay, so that's really for what's going to happen to rate levels. And it's possible that rates can go up and bills can go down because if you save a bunch of energy in terms of throughput, right? So typically our affordability metrics are utility cost test, ratepayer impact measure, and those just account for things that are in the revenue requirement, up or down, and sales. On the right, the realizing value for grid and community starts to bundle in some other things like reliability levels. What's my benefit are better reliability? What's my benefit of a cleaner environment? In the standard practice manual language, you get to total resource cost test, societal cost test. And then if you have a participant cost test, if you have a technology that requires a customer to opt in, that's just like looking at, well, what's the economic value proposition to them? Are they going to opt into your efficiency program? Or if it's an optional TOU rate, are they going to opt into it? How does that look from their perspective? And so between these three, you kind of cover the cost testing world. For grid modernization across the jurisdictions that we looked at, everybody did a revenue requirement impact, a rate impact. It's almost pretty much any time a utility is asking for authorization to spend money, there's associated with that, well, what's the revenue requirement impact? Pretty standard practice across all kinds of different investments. And then everybody also looked at, well, what about if my goal is to improve reliability, my goal is to reduce emissions, what have you. They've got in their benefit cost analysis, it's some of the green elements. And we'll talk about what people put in on the sort of total resource cost test bucket. And so it's really a benefit cost analysis that's done in that green circle. It's kind of the industry standard, while making sure that rates and bills don't go up from the sort of affordability and rates. So it's actually two studies is what I'm saying. It's actually two analyses. An overall life cycle benefit cost analysis that includes better reliability, environment, whatever factors the commission wants to include, and overall affordability impact and rate impact. Hopefully I didn't muddle that too much. Okay, let's go to the next. So we're going to kind of drill down more and more and more into these. So the revenue requirement reduction. So there's sort of two components within the revenue requirement utility cost test piece: energy savings, capacity savings on the generation system, transmission, distribution, sort of all the way down through the supply chain, renewable integration, avoided O&M, for example, labor, truck rolls from meter reading, restoration of outages, et cetera, avoided capital. So if I don't have to buy as much as soon. So those are things that can directly offset what would otherwise be in our revenue requirement calculation. Enabled cost savings is the additional savings you can get because you've got this platform and you can provide other services on top of it. Like maybe one example would be time of use pricing. It encourages customers to shift. That could provide energy savings, capacity savings, generation, transmission, distribution. This filing is for example, which is in our hypothetical filing, a metering and billing system that can deliver that, but it's not necessarily the filing for the TOU rate. That's fine. Most places will put the benefits of what their expectation is. We're going to head this direction. We're going to put our energy shifting value in there. Okay, but slightly different category, enabled cost savings. Service quality improvements. There's the reliability improvement, the resiliency improvement, and we're going to kind of get to how different states have looked at the difference between reliability and resiliency. Improved DER interconnection, customer service improvement, maybe fewer phone calls to the phone bank, that type of thing. And then the last bucket, externalities. So environmental benefits. So a long list there. Those tend to be very custom based on where you are and what the topics are that stakeholders are focused on. Sometimes you see macroeconomic benefits like jobs, GDP, improved safety, improved customer's choice. Now, in putting this list together, you know, as you look at the studies around the country, there's a lot of different words for the similar things. So this is just one set. You might see some words that are slightly different, but it's basically the same thing. The other thing is we went through and we did some different shading of colors. The like dark blue is quantified and put into the benefit cost analysis. So the life cycle generation capacity savings is a line item in my benefit cost analysis, just for example. Then the second shading is quantified, but it's just reported in there. So like improved DER connection, hosting capacity. I think I can get this many more megawatts on, that type of thing. Doesn't get multiplied by it's worth $10 per megawatt for my customers for additional hosting capacity. But if that's a goal of my project, then I want to report out and quantify what that is. And then some things are more qualitative, improved safety, improved customer choice, some of those types of things. You'll see that they just talk about them in a way in their filing for the investment that is, but there's no number like how many lives, how many fewer people will be impacted, or that it's sort of, you know, they don't try to do that piece. So hopefully that mapping, and the reason why I've divided between revenue requirement reductions plus these other categories is going back to those sort of two analyses. Most programs always do well, what's my change in revenue requirement? So you need to, you know, so those are just those components. And we'll see that a little bit more later. So if we go to the next slide. Equity. Okay, so equity is in every recent grid modernization. It's addressed in every recent grid modernization filing that I've looked at. But the benefit cost analysis itself tends to be all customers. So we're not trying to focus a benefit cost analysis for disadvantaged communities or this community or that community. Usually the BCA is everything. And that the plan for deployment of the grid modernization is where the equity comes in. And so I've got 5 examples here that are, you can see rate levels and affordability of electric service. Super important. I mean, that's kind of fundamental. Even without grid modernization, just can we keep rates affordable? That has a big impact on utilities, customers' bills, especially in disadvantaged communities, has a big impact on rearages and all, you know, it's a top of mind question that you want to address in this, even your system-wide BCA for the impact on revenue requirement will evaluate. The second one you see is differential reliability by area. So how are our disadvantaged communities doing on our reliability metrics? Or sometimes you see things just as simple as like, we're going to have a feeder program. We're going to take the worst 10 feeders in our service territory and we're gonna upgrade them each year. That's gonna be on our to-do list. Where you're looking at, you know, trying to make sure that you're providing good service for everybody. The third, access to technology, including distributed energy resources, electric vehicles. What's the hosting capacity? Matt, can I interconnect behind the meter solar in my disadvantaged communities or in other places? What about EV potential? We don't want, you know, there's a lot of people talking about charging deserts, which is more of an investment concept, but you want to make sure that you're enabling everybody along an energy transition, especially if we're shooting for 80% new cars are all electric. We have to be able to interconnect them. Sometimes there is a local air quality aspect to this. You can see that. And then, and making sure, you know, one of the solutions to the electrification is electrification. So, for example, in California, the non-attainment zones in the Bay Area for NOx non-attainment have looked at, we're going to make rules for electrification. So you have to electrify requirements, but then the grid has to support those electrification investments. So it's like a local air quality driven distribution grid investment decision. And then finally, jobs and workforce development. So how many jobs are going to be required to roll out my metering infrastructure? Whose jobs are those? Do I have job training? There's other elements of equity in that whole space. So those are the sort of ways that I've seen equity addressed in these grid modernization plans. If we go to the next slide. Utility cost recovery and cost control. We're not going to talk about this that much, but just to point out that a lot of states have a longer term 10 or even 15-year grid modernization plan, like all the sort of the big picture, but it doesn't ask for any money. It's just, here's the vision for how it's going to roll out and look out along the way. And then it has, then, okay, maybe that comes along with an initial funding request to do the first part of my plan. And then there's some measurement and investment and so on. So that's just a common way. It's helpful because then you kind of know where you're going, but you're not necessarily authorizing all the money to get there all the way for 15 years. I don't want to go through these specific cost control mechanisms too much. We'll get to that more in the next section. But if we go to the next, I think this might be time for questions. Yeah. Okay, so I know the frameworks piece was kind of a lot. We talked about the benefit cost analysis versus least cost best fit. Talked about which benefit categories. Talked about doing two analyses, one on revenue requirement and rates and one on sort of an overall life cycle benefit and cost analysis. Some jurisdictions. Any questions at this point? You all wanted to?
Would anyone in the room like to ask a question at this point? Yes, Mr. Desjardins.
Yeah, thank you very much for the presentation. On slide 20, you know, something about community in there, and you reference measuring benefits for greater reliability and environmental attributes or something like that.
Yeah.
And how do you go about measuring that? I mean, from a quantitative standpoint, or can you?
Yeah, you can, and it's routinely done. And we're going to talk about some specific ways to do that in the fourth section, where I try to like go under the hood a little bit about how, because at the jurisdictional level, it's kind of high level. It's like $20 million worth of environmental benefits. And you're like, well, okay, how did I get there? And so we'll talk about how, you know, there's some sort of standard practice for how to get to those. Also, similarly on the reliability side. So we can talk about that.
Right, Mike Antonio with Excel Energy. There's a issue that wasn't raised that I didn't see on externalities was a rating agency kinds of, input. So the rating agencies that rate the utilities and their, relative, performance, you know, cost of, borrowing, et cetera, is affected by that. Have you seen any of the, analysis that takes that into account? Just curious.
I don't know if I've seen that so explicitly, but one of the things that's really critical here is we're spending money up front and we're getting benefits over a long period of time. So when you do life cycle analysis, it collapses all that and doesn't tangle with the reality that I might need a rate increase and then provide energy benefits later. And, you know, the rating agency could be looking at, well, how much debt do you have? Can you borrow that money? You know, getting into that, you know, yeah, this looks like it's a great idea from a life cycle, but can your balance sheet hold it up and keep a good credit rating, which is so important to keep our debt costs low. So I think that is implicit in how we collect them. There's calculating the revenue requirement, and then there's sort of like how we collect it from customers. And I didn't focus on that too much, but that is a big part of these filings. Like, how am I gonna get the money? I mean, is it gonna be a surcharge? When is it gonna start? Is it gonna go? You know, so I think that the mechanics of collecting money from customers and observe and realizing the benefits kind of ties into that question. I think that the presumption is you have to keep your utilities credit ratings positive, you know, in good place, right? We need financially healthy utilities. Things can happen. We might need big investment, you know. So I think that's kind of a presumption along a lot of these filings. And that might also be why you need to phase other things like that.
Yeah, my name is Nancy Burns. I'm with El Paso Electric Company. And I'll just sit up here so.
It's good because then folks over here.
So everyone can hear me. I appreciate your presentation so far. Complexity. The complexity of the whole, you know, rate making, you know, analysis and the models, and obviously there's just many things, the hugely broad scope. But is one of the assumptions of the projects that we're talking about here is that these are utility initiatives where the utilities are coming in and asking for the costs of the investment prior to the investment being made and in service. Is that like a fundamental assumption of what we're talking about?
Yeah, most, I think, I don't know if it absolutely has to be that way, but yes, most utilities want to have some assurance that it's going to be prudent and, you know, reasonable investment. So they file ahead of spending the money and have that conversation with the regulators and the other stakeholders around, is it worth it?
Okay.
So you know, I wouldn't say it's absolutely 100% all the time. You know, it's a really broad set of categories of investments we're talking about. And, you know,
I'm just envisioning a world where a utility comes in for a rate case after, you know, meeting, you know, putting in plant and making their compliance reports with the regulator, and the utilities invested in distribution and transmission and generation to meet a need, right? A need's been established. And the goals of the investments are to provide safe, reliable, and continuous service. Okay. And, you know, coming into that proceeding and then, you know, having to, you know, justify plant in service based on cost benefit analysis. I mean, it seems to me it's a very different thing having a grid mod statute where you come in and there's, specific, upgrades that you're asking for, and you're asking for the money in
Yeah.
advance through a rate rider.
I feel like the difference is, and utilities work this differently, but a lot of utilities have like an established like engineering spec on their distribution system. They have an established like reliability criteria N-1, like some standard industry standard processes that they do. They've forecasted the costs in the GRC, but load growth, wiggles, things change, storms occur. And they're just, so that sort of business as usual, I think gets handled in the rate case process. But I think all of the jurisdictions, we're about to do the jurisdictional review, work much more like what I see in New Mexico, which is here's a list of investments that comprise grid modernization. Are they, go through the process of figuring out what that investment looks like. Are they reasonable costs for customers? And then get approval and then launch your grid mod plan. Yeah, it's so hard to generalize because 50 states, think how many utilities. I can't promise you a utility hasn't done a grid mod investment and then gone back later to ask, but I don't think so. Yeah.
Zach Pollock with Excel Energy also. So a big question going back to the least cost best fit. The example you gave before when you're thinking about distribution capacity planning, you're typically thinking reconductor, new transformer, new feeder, et cetera.
Right.
As we think about it, we have all these emerging priorities where it's not just how big does the wire need to be or what other things we do inside of the wire. But if we're going to go out and go touch a line, we're thinking about, should we put wildfire safety settings to reclose the line?
Yeah.
Should we harden the line, conductor, those types of things?
Right.
So curious to hear what you've seen in other states in terms of sort of the blurred line between least cost best fit and some of the other activities that are, driving beyond just capacity planning.
Yeah, I think that the grid hardening pieces that you're talking about can become, I feel like it's prudent to like say we're going to change because wildfires, because of the challenges. We want to change our standard feeder design to include, the telemetry recloser, whatever new standard you want to move to. And I think that's probably, it. And so in that way, it does look like a benefit. It does look like a grid modernization investment. And then I think it's a question of, is that type of grid modernization investment benefit cost analysis or least cost best fit? Once it's your new standard, then it's least cost best. That's just a feeder. That's just a new investment that you're, kind of tried and true, right? You don't want to be coming back in and all that.
Agreed. Yeah, I think that's easier said than done.
Yeah.
Going up, but fundamentally agree.
Yeah. Other questions? I still have 2 more sections and let's check our time. Are we doing okay? I can go a little faster.
I think we're doing okay, but.
Okay. I think it's useful to do, is it useful to do questions a lot as we go? It kind of breaks up my day too, so that's good for me too. Okay, great. Let's go to the, so if we go to the next slide, it just lists out some of the proceedings that we were looking at and investments. And this is not comprehensive. There have been many of these. You saw the state's diagram, many utilities, many places, but they're relatively recent, last 5 years, most of these. And I think it's just useful to look at a high level. What we're going to talk about in this section is sort of what you see when you go through the testimony and the filing. And then the next section, we're talking about some of the methods that could have been used sort of more behind the scenes to develop the numbers. So go to the next slide. Okay, so what technologies were included in each of these jurisdictions? You can see metering, fault indicators, voltage VAR management, just are all pretty much a yes across all of these 10 proceedings. DER management means different things. Am I asking for a full-blown like DERM system, something else? That's a mixed use or a future case and public services case. And then customer information platform, am I using that data and giving it back to customers to enable better energy decisions? It's pretty much a universal yes. So, like I said, this is not a comprehensive, but I think from this, we can see sort of what's typically included in that bundle of grid modernization investments. If we go to the next slide, talks about benefits included by jurisdiction. And here we get a little bit more differences. And again, each of these states and utilities uses different names for some of the same things. So we've tried to consolidate under one set of language, but reduced operational costs, whether that's, meter reading or service restoration, energy savings, avoided capacity and or T&D investments, reduced outages, societal benefits. Are they in or out? So the last two categories fall in that doesn't impact the revenue requirement, but it's included in my BCA kind of category, reduced outage. So am I having better safety metrics? What's that worth to customers? We'll work on how to measure that in a sec. Societal benefits, those vary by which ones, depends on which commission we're talking about, but a lot of the states include those. If we go to the next. So it's kind of like a cooking show where we just jump to the answer for each of the 10 jurisdictions. What we've done is put and this is the list got a little shorter because this data is actually not available in all of these. But what's the total cost per customer, total benefit per customer, and benefit cost ratio? And the reason I wanted to show this sort of high level overview is, first of all, look at the cost per customer. So this is ranging from $280 a customer, public service, to $1,600 a customer in Massachusetts National Grid application. So that's how much money they're spending per customer. And then, okay, so what's the benefits? When I look at those life cycle, what's my benefits? And you can see that these benefit cost ratios are, around 1, to be honest with you. So a few things I wanted to say. So the cost per customer, to me, fairly, like these are real investments. This is not a small thing. Whether it's a lot of money or not a lot of money, I'm not going to judge, but it's like a real investment. The benefit cost ratios of around 1 to 2 mean this is the kind of investment decision that analysis is really important. Like if they were all benefits of 10 times cost, then okay, I can kind of pretty much assume like, all right, I'm gonna be good. This is a worthwhile investment. But they're like between 1 and 2, so that means my assumptions that I'm going into and baking into here, maybe my scenarios, a number of these jurisdictions do scenarios, really are important. This analysis that I'm doing really drives the answer. I guess that's my other point. I think that's all I wanted to do on this one little section. I could be wrong. If we go to the next slide. Yeah, so questions on this piece from the commissioners or our audience, just like on that top level, what do you see when you look at the filing? Because our next section, we're going to drill down into like, well, how do you get to those numbers? Best we can. All right, let's keep going. So the process for benefit cost analysis looks something like this. And hopefully it's big enough. The first thing is usually you have 2 cases. A measure case, which is with my investment, and a reference case, which is what would happen without the investment, my sort of existing standard practice. So all these benefit cost analyses are driven by the differences. And so you've got a baseline case. And the results can depend as much on your assumptions for what happens in the investment case as it does for your reference case in terms of the data that you have there, right? So just to know, those are both important to define. For your measure case, okay, so it's got some investment costs. You can compute the annual revenue requirement going out in time based on what the investment is, capital, O&M, what have you, in terms of its cost. Pretty standard utility rate making. For the reference case, the first step is, okay, impacts. So what happened? I made the investment. What's the difference? And did I save energy, capacity, reliability, improvements, environmental benefits? And those impacts are, dollars per kW year, SAIDI, delta, SAIDI, safety metrics, that type of thing. And then with those impacts, I get sort of two bundles of benefits. Ratepayer cost reduction. So my energy savings means it reduces my procurement cost, for example. And then another category of benefits that don't affect my revenue requirement. And then you see on the right-hand side, you end up with the results that are sort of two things. You have a revenue requirement, rate pay impact analysis that includes the costs and benefits that affect customer bills. And then you have a life cycle benefit cost analysis that runs in parallel that could potentially include expanded set of benefits that are worth considering, like reliability or environment or other things that are not on the bill. So that's the big framework. And you always need this counterfactual, and that's easy to forget. So worth stressing. So we go to the next slide just to zero in a little bit more on this impacts. So I've got on the upper left, the two cases, the measure case and the reference case, and then the impacts. And now we've started to drill down a little bit more into, well, what kind of impacts? Peak kilowatt, on-off energy savings, O&M savings, SAIDI, safety, CAIDI, avoided equipment, capital, renewable interconnection. There are a number of different potential, depending on what technology it is, what benefit you're focused on. With the impacts, okay, that's fine, but now what are they worth? And so then in order to do this analysis, you need a forecast of what's my energy costs, what are my capacity costs, equipment costs, what have you. And then you can multiply down through and get reduction in revenue requirement, monetized improvement in customer service quality. And we'll talk a little bit more about how people do that pink section. And then the environmental like externality piece on the right, with the red and green kind of going to that other analysis of overall lifecycle benefit cost analysis, but not the revenue requirement or rate impact. So we go to the next slide. Just some examples. We're going to show a couple of live examples, but before we dive down into that, AMI outage notification. So I know where my outages are sooner. How do I estimate the value of that? So first I want to estimate what my SAIDI improvement is. If you look at this formula, basically it is how much faster can I restore service per outage? That's in the parentheses times how many outages per year give me an overall SAIDI improvement. Or on a VVO type of analysis, it's, well, how much energy savings do I have because of better voltage levels for my customers times the portion of load that are on circuits I'm targeting with my VVO gives me my kilowatt hour savings. You get the idea. You want to build up metrics that you can then multiply by your value. So we go to the next. I'm going to keep moving because I know there's going to be some questions. Big time. We keep going. Yeah. So accounting for benefits and costs over time. And we were talking a little bit about this for a question at the between the sections. The cash flows for these things look like in the red here, this chart. Costs are in red. And you see, it's kind of an upfront investment with investments kind of moving along. So it's not all, this is from the National Grid's benefit cost analysis. I think most utilities will do this annual revenue requirement type calculation, but you want to do it over the life cycle, reflect all the costs. the rate impact accounting, I think that the toolkit that we have for calculating revenue requirement for a utility investment just kind of comes fully to play here. Nothing new really there. The thing that is new is there's some new benefits potentially in that benefit cost analysis, and there's not often a lot of transparency or clear articulation of the assumptions behind how to calculate those pieces. In other words, the costs are pretty well known. We can report on them, and then the benefits. I think that, you know, most filings could do better, quite honestly, on the transparency of that side of the equation. What else do I want to say about this? Oh, yeah. So notice in this chart that stole from National Grid, it's got error bars. And so different jurisdictions add uncertainty. And a lot of these things, we don't know exactly. So we might have an upper bound, a lower bound, and then the results sort of bound the case. And then we can just sort of move it out over time with the two scenarios. And then we could end up with a result that gives us our costs are X and our benefits are between, you know, Y1, Y2, something like that. Okay, if we go to the next. Oh yeah, so here's the accounting for uncertainty. Some examples. I guess to say, I don't really want to dive into the specific cases here, although one, I guess, important thing is that if for programs that have opt-in, opt-out, that seems like a pretty common spot of uncertainty. You know, what customers, how many customers will stay on the program or drop the meter or what have you. The other area of uncertainty that I've seen is on the load shift from a time of use pricing. You know, is it a big shift, a small shift, that type of thing. This case here has a high DER adoption case or a base case and a low DER adoption case. All of these examples on here, I think, are around the customer response and take up of the customer facing technology side. That's where the scenarios sort of are. I'm providing new opportunities for customers, but how much will they take it up? I can have, you know, bound my estimates. And all that really means is doing the analysis for one set of assumptions and then do the analysis again under a different set of assumptions and then characterize the results using bounds. That's all we're doing. The next slide. Long-term forecasts of loads and impacts. So the investments that we're talking about are really long life, like really long life, right? And I just said we're going to do life cycle analysis, so we're like out there in the future pretty far. I stole this load forecast picture from a PNM, but you know, every utility has a forecast. It doesn't necessarily go out that long. And you know, if the purpose of my grid modernization investments is to connect the EVs, then that could become important in terms of how long I'm looking out. If it's load impact, if it's flexible loads, you know, getting out there pretty far in terms of, you know, how on my metric of how many kilowatts did I reduce because of my load shifting for pretty long. Let's keep going. So I wanted to walk through, okay, how do you calculate these benefits? So energy and generation capacity savings, I think, are kind of the most universal. It's important for some of the technologies, Voltvar optimization, whose purpose and use case is to save energy, customer information management system, whose purpose is to inform customers to make more efficient choices, time of use and dynamic pricing. When you pencil all the way down through, what you're really getting to is peak load impacts, energy impacts by time period, time sum value. The example of the time sum value that I showed here is from the Mass Save program, the voided supply energy supply cost study. There are other places to get this. I'd say there's a typical approach and a full integrated planning approach to this. The typical approach I'm showing here with this Mass Save, which is some adopted forecast of the marginal energy and capacity costs. So maybe you've got those from your efficiency program. Maybe you've got those somewhere else in your filing. Maybe you've got them as an output from your integrated resource plan. The full integrated planning approach would be to embed load flexibility efficiency into the actual IRP. And then you're solving for, well, how much less infrastructure do I need to build? That's my capacity value. How much less energy do I need to purchase from markets? I think 10 out of 10 of those examples we looked at are more on this like typical approach, the best we could tell. In terms of like they had their adopted energy and capacity supply forecast, and that's what they put in. But it's interesting to think about in a time when you have a rapidly changing grid, renewables, lots of energy storage, of a full integrated approach might be a better way to capture those benefits. We go to the next slide. A VVO example that I did for a large municipal utility. I know these numbers are really small, but this is the utility cost test, and I just wanted to kind of provide some, I don't know, reality to it. So it's got for their whole service territory, how many feeders do they have? How many are they targeting with VVO? Given that, what's the cost from a vendor for hardware, software, maintenance, professional services on down? What's the revenue requirement of that? In this example, it's 46 million, something like that. On the right-hand side of the equation, how much energy is running through those feeders per year? What CVR factor do I think I can get on those targeted feeders? It's my average voltage reduction. Gives me an energy savings metric, megawatt hours per year. And I've got an average wholesale energy price of energy, $32. So I can end up with a energy savings per year and a net present value of 74 million, something like that. So this is a pretty straightforward utility cost test. I'm substituting capital for energy, reducing energy savings of my customers. The VVO in this example worked out to something like 2 cents kilowatt hour. And it's saving 3.2 cents. So compare. Okay, so this looks like the energy benefits of this VVO investment make sense. I'm not talking about exactly which utility this is, because this utility actually didn't invest in the VVO system. There's some different, everybody is within their own context. A lot of these were on their lower voltage 4 kV system that were slated for replacement. So they were kind of thinking, well, maybe I just do that. There's other things about, well, that's $47 million of revenue requirements. So that's in my, do I have room for that in my capital program, et cetera. So there's different considerations, but this is sort of how you, hopefully that provides a little bit better example of like how you might go about something like this. If you go to the next slide, VVO has this sort of extra complication where the energy savings is behind the meter. So it looks like a supply side investment that reduces customer energy consumption. So it kind of looks like an energy efficiency program. So it will pass, as we saw, the utility cost test, but doesn't necessarily pass the ratepayer impact measure. In other words, rates go up, bills go down, right? It's significant though. In this example that I was just showing, if for that utility, the bar on the left, the orange, blue, gray, yellow is their current annual energy savings from their customer program energy efficiency portfolio, and the VVO is the stack is the right on top or to the right. So it's like half again as a bigger efficiency program overall with better voltage management.
Mr. Price, I just wanted to interject that based on our schedule, we've got about 10 more minutes allocated to the presentation piece. And, you know, I don't know if you're going to get through everything you want, but just wanted to let you know that, and that would include questions as well.
Okay. I think that there's a couple more key things I wanted to get to, and then we'll go for questions. Thanks for telling me. Yeah, let's keep moving. So we go to the next slide. Distribution capacity savings. You know, there's been a lot of work on integrated distribution system planning. How do we account for the distribution capacity value? There's a set of both utility and customer facing distributed energy resources that can provide distribution capacity. A typical approach is to take a marginal distribution capacity cost forecast, whether it's from your efficiency program or whether it's from your GRC. Very typically, it's from your GRC marginal cost testimony on your distribution avoided costs. That's a typical approach across all those. I think there's an integrated distribution system planning potential way to do this as well that looks at your actual locational area specific distribution costs. So either way, but again, the surveys that we did really looked at this typical approach. We go to the next slide. I had some examples of how to do more of an integrated distribution system planning approach, which is what's my capital plan on my reference case? So how much capital am I going to be spending over time? And then what's my capital plan in a case where I have embedded load flexibility or other investments to reduce my distribution capacity peaks? Take the difference in revenue requirement and the amount of load reduction I needed to achieve it, and you get this forward-looking distribution avoided cost type calculation. I'm going to go fast. All this is a difference between the formulas and stuff. It's just difference between two present value revenue requirements. Go to the next slide. We did this in California, where we looked at all the IOUs, distribution capital investments, and the growth driving those investments in each of the areas. And you end up with this sort of distribution of avoided cost depending on where you are on your system. So this is really different looking than like using the marginal cost from your marginal cost witness in your GRC. It's a very local planning integrated approach. And when you do this, you will find you have some very high cost areas to serve where it's really worth a lot. And then you have a lot of areas where there's excess capacity and it doesn't provide you anything. So a lot more detail on this in this publication that E3 supported the Berkeley Lab on locational value of distributed energy resources. Keep going. I'm going to skip load flexibility in the interest of time. The last piece I think that's important to touch on is the reliability versus resiliency and how folks are wrangling with that. Reliability is really measured in terms of service continuity, what's the frequency of your outages, the duration, your sort of standard reliability metrics. Resiliency has really been more about how do I get ready for like really major disruptions. California's been focused on wildfires, Florida's been focused on hurricanes, like massive events that have low probability for a particular area, although increasing, and very large costs. The analysis that we see are typically in that reliability bucket. where you take a change in SAIDI, a change in safety, times a value of dollars per kilowatt hour unserved, and calculate a reliability improvement. Resiliency generally tends to be a separate proceeding where it's, not trying to do, well, what's it worth to customers, a full BCA? It's more like the results are catastrophic. They're low probability, but catastrophic. What areas can we harden first? How much can we spend on that particular area? And doing more of a resiliency from that perspective. So we go to the next slide. I know we have to be done. I'm gonna skip through this. I did one example using the ICE calculator for New Mexico, because we had that question about, well, how do I value reliability? So the Berkeley lab does update its values, and they are state specific on cost per kilowatt hour unserved, cost per duration for both residential and commercial type customers. And you can multiply it once you have an estimate of your improvement in your reliability metrics, SAIDI, safety, CAIDI, you can multiply across and you can get to an estimate of what's it worth to customers to have fewer outages, duration, to compare against the investment in faster service restoration, et cetera. Okay. Can we just, I think that's the last piece that I wanted to make sure, because we had a question on that. We keep, just go to the click through. We're going to click through that. Yeah. The last slide I skipped was on the environmental benefits. So if somebody wants to, I know we only have like a couple minutes, but if somebody wants to ask about that, go ahead.
Let's open the floor up to questions about any aspect of what Mr. Price has spoken about today. I've got a question to maybe start us off. You talked about this approach of requiring a long-term grid modernization plan that did not include a request for funding, and then having the funding requests come separately. How common is that? And do you also see that structure where jurisdictions with a grid mod statute?
I think a lot of times that is paired with the initial request to get going. So there's like a longer term plan and then a request to approve like the first sort of tranche. That might be the same proceeding, but it might also be a different one. Or I think it's pretty common to have a longer term, longer range vision of where we're going. And, the approval process really varies by state, whether it's in a GR, sometimes it's just go to your GRC and ask for it there, or approve it in a separate case or proceeding. But I think long-term planning is, it's used. This is a multi-year, this is a big project and a big investment over multi-years in our distribution system. So, it makes sense to have a view, where your bend posts are. I don't know.
Right.
Yeah. I don't know if that answers your question exactly. I don't know. A follow-up could be to go back to those jurisdictions and pull out that specific question, like how many had the long-term plan versus, but I don't have that. Like,
That's fine.
That's
fine. Any other questions?
One quick one, since there might be like 30 seconds left, can we look at that environmental slide?
Yes. Let's do it. One back. It's always the slide at the end of the deck. So the environmental benefits come from sort of two main categories. Less energy use, which translates if you're using fossil fuel generation to air quality, pollution. And the other aspect that people look at is land use. So if I'm doing high renewable build outs and I build less solar, large scale solar, then that's some number of acres that I'm not building. And so across the environmental spectrum of benefits, there's the more common to less common. And those that we looked at, the greenhouse gas emissions piece, most common. And then I kind of show this triangle. The second piece is criteria emissions. If you have regions that don't have their NOx attainment, reduce water use, reduce land use, and other benefits. I show an example here of a project that E3 did with stakeholders to kind of walk through their tally. And they really get down to, what are the physical impacts per megawatt hour reduced. So it's a delta megawatt hour times, and then what does the value give us? And if you look at their carbon, they've got quite a bit, 7.2 cents. So they're looking at avoiding new renewable plus balancing as an alternative, essentially, in Sacramento for their carbon offset. Fugitive methane, if you can reduce natural gas use, there's upstream, there's carbon savings from not the combustion, but then the leaking methane on the way to the power plant, it's a piece. But look at the values start to go off like real small. And so, in this example, with this set of stakeholders, you end up with, really, it's all about the emissions. And that's what we're trying to achieve. And these other pieces are fairly small, right? Less than a cent. In these examples. I guess the other thing is, it depends a lot on the state policy of like, do I have a greenhouse gas emissions reduction goal? Do I have that this grid modernization investment can support? And if it does, then like, let's count that value because it will help us get there farther, and faster.
Great. Mr. Price, thank you very much. That was a very enlightening presentation, and appreciate your input on this. And I do believe this presentation will be filed in our docket for the rulemaking. Thanks again for everything.
Yeah.
We are scheduled to take a break until 11:20. If there are no objections, then we'll do that. Thank you.
Thank you very much.
It's 11:21. Let's come back out of break. Next on our schedule, we have presentations from our 3 investor-owned utilities. 20-minute presentation each on their responses to our 5th bench request order and questions by the commission as well as others in the audience. Do you have a preference as to who goes first in the lineup? Okay, Mr. Fenton has raised his hand here, so let's go ahead and start.
Good morning, Commissioners. I'm Mark Fenton, Executive Director of Regulatory Policy and Case Management at PNM. And today with me, I think you all know Omni, but you may not know him, as in the title I'm about to announce. Omni just got a promotion here recently. He's now the Vice President of PNM Operations and Engineering at PNM. That was effective about 2 weeks ago or so, I think. So got a different title than the last time he was here. Always appreciate the collaboration on these workshops, including today on grid mod. Appreciated Commissioner Ellison's remarks at the beginning. We had sent a letter on May 6th, I think, expressing some concerns because we have a pending application, and I'm glad you sent the amended notice out, and Commissioner Ellison had some remarks today. So we're certainly comfortable with what we're doing here today, and appreciate Mr. Price. That was a good comprehensive presentation this morning. One thing we're going to focus on the 5th bench request. Just after listening to the presentation today, I wasn't planning on saying anything, but I would like to make one short remark. Just watching all this and the discussion on the CBA today is that I think it's really important. I know Mr. Price put up the grid mod statute up there, and you could see all the detail. And I think in 2020, when they adopted that legislation, it provided a lot of policy guidance on grid modernization. So at a high level, when the commission is going about developing a rule, I think it's going to be important to stay aligned with the grid mod statute that we have in New Mexico. Not every state's, I know we talked about what other states are doing in terms of cost benefit analysis and using that to determine the reasonableness or using that to determine public interest. But I think it's also going to be important in that rule to stay aligned with the statute itself, because my recollection of that statute is it does have a lot of policy guidance. It does provide some specifics on certain types of projects. Not that they can't be, reasonableness and public interest are important, but I think it's important to stay aligned with the statute. So with that, I know Omni is prepared to talk a little bit, highlight some of the key elements of the bench request and some other remarks.
Good morning. Thank you for this opportunity. So we don't have any specific PowerPoint slides. We'll maybe cover just a few things and some of the topics. And then if you have any questions, feel free to interrupt us at any point too. Happy to answer any questions or go into any topics that you have. But as Mark mentioned, I'll just maybe hit a few of the highlights. We've really appreciated the opportunity to go through BCR process. Utilities have used that for a while, but grid modernization and some of the other exercises that allowed us to dig into them a little bit deeper. And one of the things that I've realized is there's a lot of really good things that we invest in a utility. But really the question becomes, what are the great things that we need to be investing in? And how do we rank and prioritize those? And I think that's one thing that we can gain from a BCR. And I think it's important that when we go through the exercise of the BCR, as Mr. Price pointed out, is that we're aligned with strategic objectives. And so what the approach that we've taken really at PNM, and these aren't innovative, I'll just maybe highlight some of them so but we do plans, we think of them in 5 core areas of our business. Right, we have customer programs, we develop customer programs and how do we center around the customer. We build distribution plans There's a lot of exercise that goes around how do we advance the distribution system. The third one was our resource plans. How do we actually build out the generation resources to serve customers? And that comes in a lot of different mixes. The fourth one is our transmission plans, which we have 10, 20-year planning horizons. There's a lot of activity and a lot of spin in the transmission plans. And then the fifth one that really kind of encompasses it is how do we do all the asset management around the existing assets? And so when we think about those plans, they all have to work in concert, right? If we neglect one and all of our resources and energy go to one, then we neglect another one. So we do have to be very balanced to that, make sure that they're in that point that they're meeting the overall strategic objectives. And so our Energy Transition Act and the grid mod legislation have given us things to point to try to align our objectives. I think it's very important that then when we develop our plans, we align with strategic objectives that align with those legislative goals, with regulatory goals or other stakeholder goals. That kind of brings in the aspect that one of the things that we've seen in exercise of a cost benefit analysis is involving stakeholders early in the process. So we map out maybe gaps. So we have an existing infrastructure. There's a gap in where we want to achieve or what we're trying to achieve in our goals. So you build kind of a roadmap or a technology roadmap, which might have a mix of different technologies. And then at that point, then it's important to grab stakeholders to understand how do we measure that, or how are we aligned in objectives, and are we meeting the right objectives? And I think that's the input from stakeholders that can be very valuable in shaping the plan to make sure that we have the right plan to meet the key objectives. So then, as mentioned earlier, it's important we dive in and we do real calculations that are quantifying as many benefits as possible, right? Some of them we talk about them being qualitative, quantitative, and some of them become more challenging, how to actually quantify a benefit. We talk about greenhouse gases and some of those other things. There are references out there in the industry that we can lean on. And I think it's important when we conduct BCRs that we're very transparent about what our sources are, the calculation and the methodologies in which we calculate those benefits. So I think that's important, and we should keep those things in mind if we're going to develop a framework around cost benefit analysis that we're going to use through this process. So there's maybe, without going into too much more detail that we covered in our bench request, I'm going to pivot a little bit to one of the last questions that was in the bench request, and that was around what other fundings are we actively involved in? What else are we doing? What other outreach? So we've actively been working on applications. As you all are very aware, the federal government has funding available. We filed 2 applications. Both those were actually denied, but that didn't stop us from to go back. We have another application that we weren't the recipient of, but it's through other entities that we're studying our distribution battery projects. And we're going to study how do those actually deliver ancillary services to the grid by using DER resources. And so we think that'll be very valuable and enlightening. 2 other applications, though, that we are actively working on that we'll be filing this next week. One is a virtual power plant. So how do we take DER resources, aggregate them together, and then start delivering higher level benefits in the form of a virtual power plant? Those grants are often matching, so we have to offer something in investment. It doesn't always have to be capital investment. It can be our time, it can be our resources, things like that, in complement funding from the DOE so we can accomplish bigger goals and objectives. Those grants have a very tight, I would think of them more as a pilot, so that I wouldn't think of them as a whole scale deployment across our entire service territory, but we pick specific substations or select feeders that we're deploying the benefits on those systems. So that's the virtual power plant. The other one, and that's probably a term you've heard and seen in the industry, so I probably don't have to describe that much more. The other one that we are writing is total grid orchestration. And I should mention too, with both of these applications, we've reached out to other utilities. We have letters of interest from other utilities if we're awarded, so that they would come in and be part of it as well. But the total grid orchestration really kind of boils down, if I was going to, at the high level, the elevator speech, is how are we going to manage DERs or intermittent resources in the future? Traditionally, if we go back to our gas plants and coal plants, we had coal sitting on the ground. We had gas pipes that came to so there was a method for us to deal with resiliency through storm events, 3-day events. When we move to intermittent resources, we know that they change very rapidly and they can be affected by weather. So decisions we make today may impact us 2 or 3 or 4 days. So how, knowing a weather event is going to come in 3 or 4 days, how do I manage my resources today so that I can make it through events that are going to occur 2 or 3 days down the event? It's purely a modeling at this point. And so, but we think, and we've looked around the industry and there isn't a tool available to the industry right now. So we've partnered with Black & Veatch and a couple other firms to help us with kind of building a scope, like how would we write this and what type of model do we need? So that's in a framework, what our TGO grant is going to look like. What I would offer in those two, I feel like in a lot of these cases, we do reports, we put stuff and then we file out other places, but we don't always share them everywhere they should be shared. And I'm trying to share this a little bit publicly because when we file those applications, if there's interest to see those, if you want to see presentations, if you want us just to give you a copy of them, happy to share any of those plans at any time. So I'll kind of pause there and then open if there's any questions or other topics.
I did want to follow up. You mentioned that you'd be filing this week. Was that the grant applications
Next week.
next week? But you weren't referring to any filings here at the PRC?
No,
Okay.
no. The DOE, yeah. The DOE grant applications, I think we plan on filing those May 22nd
Okay.
to the DOE.
Okay.
Yeah. Any other questions, comments? I don't know if we had a whole lot of that's prepared unless you had anything else for us. So.
Do you have any other questions, commissioners? No, I think that's good. Thank you very much.
Thank you very much.
Thank you.
Who would like to be next? Great. SPS it is. Great, thank you.
Thank you.
Morning, Commissioners. My name is Jeremiah Cunningham. I'm a manager in the SPS's regulatory department. Really appreciate the opportunity to be here and speak to you today and to work collaboratively with you on this inquiry and bench request. I think one of the things you'll hear from us this morning is a lot of the same sentiments and thoughts that you heard in the presentation this morning. And so we'll go ahead and jump in and then be ready to answer questions. With me is Zachary Pollock. I'll let him introduce himself and then begin our presentation.
Thanks, Jeremiah. Good morning. Zachary Pollock, Director of Grid Strategy and Emerging Technology at Xcel Energy. Good to see you again, Commissioners, and really appreciate the conversation.
Next slide, please.
Perfect. So a little bit of an illustration, trying to bring to life some of the points we made in our comments here. Obviously, the distribution system is a lot more complex than a two-dimensional diagram will give us here, but this is how we're viewing the IDP, potential IDP role in the grid modernization statute. We really see IDP as providing enhanced transparency and visibility into how we do distribution planning in our system. There are a couple of key categories that encompass distribution planning. The bulk of that tends to be capacity planning. You heard Mr. Price talk about that before. That's identifying needs when we need to go add additional capacity to the system, whether that's adding new transformers, feeders, et cetera. That's the bulk of really our planning process. That also encapsulates other processes like asset health and reliability. So figuring out where we need to replace assets that may be nearing end of life or have other conditions where they'd be replaced. And there's also technology and tools that fit into that bucket. We see grid modernization as being a bit more encompassing, so that obviously can span across transmission and distribution. So really kind of an overlap with the IDP. But in terms of how we see this shaking out potentially and how the commission might consider this, and really our recommendation is that they should be separate filings. The grid mod filings or applications, and really in our view, should be discretionary. Whereas we think there's value with the IDPs on being on a more regular cadence, providing that transparency and visibility into that. I think there was a good question before on the sort of 10-year vision. I can say from our plans that we have to file in Colorado and Minnesota, there is a 10-year vision there, but absolutely there's a near-term requirement or ask from us in terms of asking for what's needed to support that vision. Really in the next, I would say 2 to 4 years, anything beyond year 5 gets a little bit uncertain in terms of the cost estimates. So I think we can probably go to the next slide.
So this slide is echoing a lot of what Zach was already referencing, but more from a regulatory framework. And the way that we see the rules and the cost recovery pieces coming together. So in the center of that is a overall goal from a regulatory framework of moving towards a grid of the future. And we think that encompasses a lot of different aspects all the way across our system and to the customer offerings that we make. Heard a lot about TOU rates this morning and different things of that sort. And then we think the outside orbit of that is all in support of that grid modernization, the grid of the future. So, grid modernization, as Zach was saying, spanning all the way from transmission through customer offerings, customer programs, should be one aspect of it, and there should be cost recovery pieces that come with that. But then separate from that, but complementary to it, all of these should work in harmony with one another to support the overall goal. Would be your distribution planning rules and requirements, as well as cost recovery pieces there. Energy efficiency and DSM, we see that being a major part of planning a grid for the future. A lot of things around, how do you offer customer choices? How do you use ICO to factor into resource planning and things of that sort as well. Obviously, there's going to be base rate cases and base rate recovery that way for your normal course of business. We don't want to see the normal course of business get caught up in necessarily in all the cost benefit analysis and things of that sort. There should be the ability for the utility to carry on their normal course of business and have that cost recovery through base rate cases. And then obviously the last piece is the customer offerings. As the grid becomes more intelligent, there's going to be more opportunities to have customer offerings out there, customer choice, to control their energy usage, the rates that they're on, and a variety of other things. So the overall goal of the regulatory framework should be moving to that grid of the future. And then these pieces on the outside working in harmony with one another to accomplish that. Next slide, please.
Dive into a little bit about delineation here between cost benefit analysis and least cost best fit. So in my mind, and you heard me ask Mr. Price about this before, but least cost best fit usually works pretty well when there's an identified need and a clear set of solutions. I think a good example of that is resource planning. So you think about your coincident system peak that you're planning to, your reliability, and you look at your alternatives, whether that be thermal resources, renewables, storage, et cetera. I think that line is increasingly blurring a little bit on the distribution side, but he did provide a good example before. When we think about capacity planning, we would look at other alternatives to mitigate a capacity constraint. So good fit there, but as I alluded to before, there are other considerations that go into our planning process, which we absolutely are starting to account for in terms of our design standards and other considerations. Shifting a bit more to the consideration of cost benefit, specifically in grid modernization, there are a couple of points which Mr. Price put up, which I want to emphasize because we absolutely agree with them. The first one is that there's not really a bright line for what is the best fit cost test. So in other words, there's multiple different cost tests, there's multiple different perspectives represented by those cost tests. In our view, we think the commission should provide some framework there on what you'd expect to see in terms of those perspectives. But we think there's value in having multiple perspectives through those various cost tests. So absolutely supportive of that. The other point that's really complementary to that is that there's really not a right answer to the cost test. it's important to weigh the outputs of those cost tests together to understand what they mean from a customer affordability perspective, from a long-term system perspective, from an environmental perspective. But in my view, in the company's view, there's really not a single right answer you can get out of those cost tests. And then as far as the actual steps in the process, we alluded to this in our comments. I think Mr. Price probably had a better elaboration of this in his slides, but really it starts with identifying the project scope, determining what are your costs that feed into the cost side of the equation, figuring out what categories of benefits would be enumerated, as well as other categories of benefits which may not be able to be measured quantitatively, but could be potentially captured qualitatively in the actual analytical framework, or as was discussed previously, could be captured more as a reporting metric. And then it just comes down to doing the math once you've got all those categories down on paper. So I think the process is more straightforward, but really the key point of this slide is that there's value in looking at those cost benefits from multiple perspectives. Next slide. So a little bit of an elaboration on how we see grid mod fitting into this. So again, reiterating the point that we think the applications for grid modernization should be discretionary and really at the judgment of the utilities, really capturing that first bullet point here. Corresponding to that, the approval process that may be independent of an IDP or other grid mod filings. We do think it does make sense to have some continuity in that 10-year vision between various grid mod filings. And that's something today we already do internally in terms of having a longer term vision of how all these things align. In terms of sort of the scope and definition of grid mod in our view, we see these as being really sort of unique efforts, and that may encapsulate multiple different pieces of it. It could be foundational technologies. We've talked about AMI here on the slide, but there's multiple pieces of that. So there's a field area network you get with AMI, which gives you communications. That may enable other pieces of grid mod filing, like FLISR and integrated volt VAR optimization. So we see the boundary as really being a discrete effort rather than individual technologies or projects. And the last point here, just to reemphasize, but we see IDP and grid mod really as being separate filings. There are obviously overlaps there, as we indicated on the first slide, but we think it's important to keep them separate, albeit make sure that the story and the narrative and vision all correspond together. So taking a step back and just providing a little bit of broader context, I think this is a perfect opportunity, especially with the Energy Transition Act and some of the other supporting policies, legislation, regulation that Jeremiah had talked through previously, kind of understanding where we're going and where we've come from to understand the importance of these filings. So I'll walk through the slide briefly, but really if you start to think back to the 1930s and 1940s, admittedly, I've only been alive for about a quarter of this slide, but I've been in the utility industry for 15 years. So by utility standards, this is like basically my first day, so bear with me. So we really haven't seen the type of infrastructure build out that we saw in the 1930s and 40s as we started to electrify rural parts of America. That persisted into the 60s when people started adopting air conditioning. They had refrigerators and access to the benefits that electricity provided. That era of load growth persisted for quite some time, really into the 70s when we started to have some of the initial policy engagement around energy crises and conservation of energy. I would argue that largely persisted through the 2000s, where the policy focus tended to shift on decarbonization, reducing carbon emissions, specifically in the power generation sector. We're really, in our view, at the bottom of this inflection point on the right side of the slide here, where the focus has shifted, or I'd say expanded, from decarbonizing power generation sector, but really to think about how utilities can be the backbone for decarbonizing other sectors of the economy. So this is a great opportunity in terms of both the grid mod statute and a potential DSP opportunity or IDP opportunity here in New Mexico. Recognizing that we are at the beginning of this inflection point and getting this right and doing it in a transparent and equitable way is going to be critical to achieving those broader economy-wide decarbonization goals and targets. Next slide.
This last slide is really a summary of what has been in the rest of our slides and the rest of our conversation this morning, but moving from left to right, the thought that the grid modernization statute, and we believe any type of grid modernization rule should have some type of cost recovery mechanism with it. We believe that that's an important aspect of these filings, that they should have a cost recovery element within the grid modernization applications. The investments approved through a grid modernization application or through an IDP application, we believe should come with some type of prudency finding, whether that's recovery eventually through base rates or that's recovery through a separate rider. But these filings should create regulatory efficiencies so that we're not relitigating the same capital investments over and over again through different proceedings. Again, the middle of the filing of the IDPs shouldn't impede things that are normal course of business. We shouldn't get to the point where we're tying up that activity for the commission in lengthy filings that have had a predetermined need. Those should move along and be normal course of business. And then the very last bullet, the grid modernization projects. Obviously the cost and benefits are to the entire system rather than being for one particular customer. To Zach's point, they're efforts, they're not particular projects. So they should be for the benefit of the entire system.
I would just volunteer 2 additional learnings from our plans that we file in Minnesota and Colorado. So in Minnesota, we have an IDP that's largely an informational filing. If there's a request there for investment approval or recovery, that has to go through a separate certification process. In Colorado, we've only filed 1 distribution system plan so far. That was largely an informational filing as well, but we actually have been working with several stakeholders to pass legislation in the state that would make that more of a cost recovery proceeding with some heightened requirements around the way we do load forecasting and ultimately the benefits our customers would get out of that plan. So given the pace of change I walked through about a slide ago here, we do see it being important to have that recovery mechanism and approval mechanism tightly integrated with a future IDP. And GridMod sort of speaks for itself. The other point of caution, just going back to cost benefit, I would encourage is I think we've seen a little bit of over engineering on some of the cost benefit streams sometimes. And when you start to get down into some of the very granular benefits on the distribution system, it can be extremely challenging to do that on grid modernization efforts that may be system wide. So Mr. Price had a slide there previously talking about how you can do a locational benefit assessment of various feeders. That may be true when you're looking at investments on a specific feeder or substation. But when you're looking more broadly at system-wide investments, that type of analysis gets extremely challenging. So just urge some efficiency and economy in any potential future cost benefit analysis that we might see in a IDP or DSP filing.
So I have a question on that. So how do you incorporate equity without locational pricing?
Yeah, I think it goes back to the sort of cost benefit analysis, which leads up to the investment decision versus the implementation. I think it's pretty challenging to reiterate a point from the earlier conversation to factor in equity into the actual analysis. The way we've done it historically has been through what we call non-energy benefits. So putting an adder on an area that might be impacted by a project or improved by a project. But generally that tends to be a pretty challenging effort to quantify that. Versus if there's approval for an investment, we move forward with that, reporting, tracking, and making sure that those customers are getting early access to the technologies or benefits that may come out of that grid modernization effort, I think is a key way to delineate.
You brought up the really the potential for cost recovery through a grid mod rider here. And, I'd like to understand why, that seems to be such an important issue. I mean, in my view, a lot of these projects are, things that you can plan for. So it's feasible to come in for a rate case and say, we're starting, this project is something we're going to start in a year, or, we've got approval for this, we're going to start it in a year. We're going to do a future test year rate case. It's going to go into base rates. I'm just wondering what, what's wrong with that model?
Yeah, appreciate the question, Commissioner. I think one of the goals, and obviously there's a lot of factors that play into that, but one of the goals is actually reducing the amount of rate cases. The workload upon the commission and upon commission staff and the interveners, I think is definitely something that has to be factored in. And I think, that's something that SPS is sensitive to. Trying to think about those avenues that we can use to try to reduce the frequency of our rate cases and the burden. Then I think that the key that we're referring to here, and rider mechanisms is one aspect of it. But I think whether or not that cost recovery happens through riders or through base rates is something the commission can determine. But the key is the prudency determination and the assurance of cost recovery through the grid modernization applications. So if we're having to come in and make these separate filings, we don't want to have to relitigate it through a base rate case. I don't know if you want to add anything to that.
Yeah, absolutely. I think the mechanism is not as critical as the prudence review and ultimately the recovery, right? So, we talked about California or saw California before. They're on multi-year rate plans. The key is that we need an environment where we're getting that prudency review and approval, the ability to move forward.
I see your point. So your main concern here is not necessarily the mechanism for cost recovery. It's if this has already been litigated in a grid mod case, it would be easier from your standpoint to go ahead and decide the rate making treatment in that case, as opposed to defer it to a base rate case and deal with the same issues again.
That's correct.
Commissioner Aguilera.
So with respect to the least cost best fit analysis, I think what your message here is that if a need is predetermined, then there shouldn't be a cost benefit analysis required. And you mentioned situations such as for reliability or resiliency. Can you just elaborate a little bit further on that? How would that need be determined in a rule or in a filing? How do we establish that that need exists?
Sure. Yeah. Let me try to provide an example to help unpack that a little bit. So when we do capacity planning for a distribution system, so when we're identifying feeders that may need to be expanded, upgraded, new substation banks that might need to be added, the determination of that need goes through our distribution load forecasting process. What I was saying on the least cost best fit is that as we're seeing additional pressures beyond just upgrading the size of the wire, so to speak, we need to encapsulate that in our planning process. But that need is clearly established through our distribution system planning process, and it's something that we have to be able to serve in order to provide safe, reliable service to our customers. My comment there was more that the factors that we're considering when we're thinking about serving those needs or expanding include things like resiliency. And that may show up in, a different design standard for a feeder versus something that I would argue is a bit more discretionary in the grid modernization statute that nevertheless may be important. That's where really I think the cost benefit analysis through those multiple lenses has a much more significant role to play in justifying and enumerating the benefits. Does that help?
Yeah, that helps. And just to add more context to kind of where I was thinking about this from is how and when can stakeholders be involved in determining that need? I think we do have similar or processes that allow for that. And you mentioned distribution planning, transmission planning could be another one. An IRP, for example.
Sure.
And so that's the part that I was wondering about. So thank you.
And just to follow up on that, I do think there is an opportunity there where we see it typically materialize is in the load forecasting process. So I think one of the key points in the earlier presentation is that there's a lot of uncertainty when you're trying to do this proactive planning to meet policy objectives. So having scenarios reflected in your policy cases or in your reference cases that may have different outcomes and allowing people to opine on that, whether it be through a litigated filing or some other venue, I think is where we typically have seen people have the ability to weigh in. Thank you.
Are there any more questions for SPS?
On the webcast.
Oh, there's a question. I see Mr. O'Donnell.
Yes, Commissioner, thank you very much. SPS has been very consistent in that it sees grid modernization and integrated distribution planning as two separate things, right? And you reified that today. The commission has always been struggling with kind of which is the appropriate mechanism for establishing this vision that you talk about, and then which is the appropriate mechanism for actually bringing projects to the commission for approval and then cost recovery. So can you tell me, is IDP part of grid modernization? Should grid modernization be where we establish the vision? Or is IDP where we establish a vision and a plan, and then grid modernization is the tool for approving certain projects?
Yeah, great question. So in my view and company's view, really, the IDP is the place where that vision exists. There's some caveats there, obviously, in that the IDP is mostly, I would argue, focused on distribution. But to the earlier conversation about thinking what it truly means to do integrated planning, even though we have the boxes on our first slide there of kind of ring fencing these filings, the organization I represent here, our integrated system planning organization, maintains our generation planning process, our transmission planning process, and distribution planning. So even though the IDP may be mostly focused on distribution, I do think it makes sense for that vision to exist there, as well as the relationships to our generation transmission planning processes.
And then you mentioned that you internally have a vision. And then just shortly after that, you use this quote: utilities can be the backbone for decarbonizing other sectors of the economy. Is that a fair statement of your vision?
I think it's absolutely a fair statement of both our strategy and vision. You look at the new uses that our customers are expecting, whether it's interconnecting rooftop solar, being able to charge one or multiple EVs. And it's kind of funny to think the full circle we've come from 2012, 2013, when we had EEI writing white papers about the utility death spiral. Now I think we're trying to manage how we can meet all this new load coming from these new uses and services in a way that's safe, reliable, affordable, and creates equity for our customers. So I absolutely think that utilities are the backbone of that energy transition.
Okay, thank you.
Thank you.
So we shouldn't trust EEI.
Maybe they're consultants.
Are there any more questions, commissioners? No. Well, SPS, thank you so much for your presentation, your attendance today.
Thank you, commissioners. Appreciate it.
Is it noon? Excel and PNM, they're hard acts to follow. I'm Nancy Burns with El Paso Electric Company, and for some reason, several people came up from El Paso and they asked me to introduce Matt Wallace. He's our project manager for grid modernization for the entire utility. So he can, summarize some of our responses, answer any questions that you have. I'd just like to say, just really starting off, thank you very much for the presentation, the opportunity to be here. I think it's a very exciting time and that the workshops are very helpful. The single biggest question that came to my mind as I was listening to the presentations and the questions was the need issue and the policy objectives of the grid mod statute, and how far does that go towards establishing policy and need, right? And where is, the benefit analysis required? I can say for EPE, we do have the Energy Efficiency Act, we have the Utility Cost Act, we have a consultant for both our jurisdictions that runs all of those analyses for us. So that's another thought that came up, what kind of assistance consulting would be required for any sort of cost benefit analysis test. that is, that comes in. And also just to sort of piggyback on some of the comments from SPS and PNM, you know, my answer to the question about rate recovery, it's regulatory, it's certainty and efficiency, administrative efficiency. So my answer would be the same as SPS's was. That's really the issue. How many times do you re-litigate the same issue? And then also just to piggyback on some of the stuff that Omni said from PNM, we have supported and participated in some of the projects that PNM mentioned, and you can see that in our comments if we don't get to them. So with that, I'll introduce, let Matt give a presentation. You guys can ask a few questions.
Thank you. It's a pleasure to be here in front of the commission, and it was a very valuable presentation this morning. I look forward to going back through it in detail when I can think about it. So El Paso Electric sees our grid modernization efforts as a collection of interdependent projects that the benefits for those projects are really derived from the collection of the projects rather than any individual project. And as such, that creates difficulties with the cost benefit analysis. So El Paso Electric has worked with a consultant to generate a very high level grid modernization roadmap that we've been using for the application of grants, trying to secure additional funding so that our ratepayers don't bear the cost entirely of our grid modernization efforts. So that roadmap that we worked with a consultant to generate is not inclusive of all costs or benefits. And really what we're running into is as we move forward, we can do a cost benefit analysis on each individual project as we do our request for proposals, our RFP process, and get true costs from the vendors. Or we can work and hire a consultant ahead of time to try and develop more detailed costs and benefit analysis. So it's really, we're concerned about being imposed a formal cost benefit analysis where we need to engage consultants for each of these projects ahead of time. So you know, as we look at the cost benefit analysis, if the commission requires us to do cost benefit analysis, we would ask that it be both quantitative and qualitative in its nature, that it would take into account the uncertainties and difficulties of monetizing the benefits for some of the very worthy benefits that grid modernization brings. So, but to be clear, to perform these cost benefit analysis for our grid modernization initiative, EP would require additional resources, both external and internal. So the least cost best fit methodology, it does seem like a valuable approach. It addresses the complexity and the interdependencies of the various grid modernization technologies. And we feel that may be a good methodology. So it maximizes value for both the customers and the stakeholders. So based on our pace of, excuse me, our pace of investment in the distribution system and capacity, El Paso Electric does system fundamental planning over a 10-year period. But that is subject to our annual budget process. And pursuant to this planning criteria,
and budget process, EPE seeks to provide reliable service to EPE's load growth in a least cost manner. So.
I'll just
Yeah.
interject
Yeah.
real quick here. And you may notice that we did attach again our planning philosophy to the back of our comments. And I think we've already submitted those in the docket. So
So I just want to go back to as we're moving forward with our grid modernization efforts, we are continuing to seek grant funding wherever we can. We have applied for a number of grants. We're happy to have provided a letter of support to PNM for their grid orchestration project. And we are interested in how that's going to turn out. But we are continuing to pursue all avenues of funding and look at all aspects of how to justify the cost. So thank you. That's all I have.
Great. Thank you very much. Commissioners, any questions?
Thank you for that presentation.
I'd like to follow up on a couple of things. In one of the questions in the last bench request, we asked about filing distribution plans, and your response was that you didn't like that idea because it contained confidential and proprietary information. Is that correct?
yeah, that's been our position with filing our 10-year distribution plans publicly. As opposed to our transmission plans, which are publicly filed, there's a lot of facilities information, customer specific information in our plans as written.
I mean, certainly there are jurisdictions which require the utilities to file their distribution plans, and it seems like they must have found some way around that particular concern. Doesn't it seem to you that that's a concern that can be dealt with, the confidential and proprietary concern?
Certainly, in particular, if it's required, we will figure out a way to do that, so.
Okay, so it's not an opposition to the concept of submitting the distribution plans. It's a concern over whether proprietary information might be disclosed.
That's correct. And also facilities information that we wouldn't want disclosed.
Okay. And to follow up on the cost benefit analysis versus least cost best fit distinction, would you agree that that a least cost best fit makes sense when a certain measure is required, say required by statute or required by commission rule, and that in other cases a cost benefit analysis makes sense?
So I think the least cost best fit analysis makes perfect sense when you have a project that is required, yes. The cost benefit analysis is useful in more traditional planning methodologies, but what happens when you have a necessary project that has been deemed necessary and you do a cost benefit analysis and it fails the cost benefit analysis? So
well, I don't think, at least I haven't heard anyone propose to do a cost benefit analysis on something that would be ordinary in the course of business, or something that is strictly required. At least I don't think I've heard anyone say that. I mean, I guess the question is for projects that are discretionary, that you can continue to serve customers if you don't do these projects. Would you agree that, one way to satisfy this reasonableness question, is the project reasonable, would be to do a cost benefit analysis?
I think in some cases, yes, cost benefit analysis is a reasonable approach. It does carry with it, some uncertainty with how you quantify some of the benefits, particularly as the projects become more complex. But I think in some circumstances, yes, it would be acceptable.
What are your thoughts around having, say, a more long-term, whether it's termed a grid modernization plan or integrated distribution plan, I'm not sure, but a more long-term plan, and then filing specific resource applications pursuant to that long-term plan?
So to make sure I understand correctly, you're talking about going ahead and filing like a 10-year plan, and then.
Yeah, let's just say a grid mod plan that you articulate, a 10-year grid mod plan that would have no funding requests, but then you separately make filings for resources that would refer back to that plan.
So one of the complexities that would create is when you're doing like a cost benefit analysis of a particular project. With grid modernization, some of the benefits come from the collection of the projects rather than each individual piece. So say, for example, like volt-var optimization. That has clear benefits, but you can't get those benefits unless you have like an underlying ADMS that's already been deployed. So the question would be is, where do you cut off the benefits that are being used to justify one particular piece versus the plan as a whole?
And I guess the opposite concern is that if we don't have this longer term picture, what we can get is these, piecemeal project applications, and we don't really see, where is this going? What's the, okay, so you want a couple of batteries in the distribution system. So where is that going? What's the plan? And it can be hard to evaluate a specific resource request, in my view, if we don't see the longer range plan.
And I'll just jump in. I mean, that makes perfect sense from a transparency point of view and understanding the context. One of the particular challenges for EPE is the economies of scale of system-wide projects. And New Mexico is 20% of the system whole. And there's different policy directives. AMI was a perfect example. It was already in Texas. It's in it was in New Mexico. So we were able to deploy. We got the Texas approval first. So, but it just presents challenging in terms of planning. We're dealing with it from the generation, obviously, integrated resource planning. But there's different criteria. There's different policy objectives, and that's just a particular challenge that EPE has. And how do you get those benefits from the economies of scale if you're just looking in New Mexico? So a lot of these projects we would like to. It's system wide, planning. So.
Great, thank you.
Yeah, no, thank you.
Are there any more questions for El Paso Electric. Anyone in the room can also ask a question or online. Mr. O'Donnell.
Thank you, Commissioner. Matt, you referenced a grid mod roadmap that appears to be internally. Has that ever been shared with the commission? And if so, in what forum?
So yeah, we have a grid mod roadmap. It is an internal document. It has not been shared.
Okay, can you describe what's in that roadmap?
It basically lays out a collection of projects, such as ADMS, FLIZR, IVVO, some management projects to manage the deployment of field devices to our system. But it's just a real high level plan. It kind of lists out the projects and kind of the goals of each project, but doesn't have any technical details with it. It does have some cost information with it, but it's an upper bound cost. So, intentionally high in its estimations.
Okay, and are you using that basic high level analysis to formulate projects that can be brought to the commission? Because we, aside from AMI, we haven't seen anything in particular from EPE.
So, yeah, we're using it to formulate our strategy to move forward. It was created after our AMI project, so AMI was not included in that. Many of the projects that are on that will undoubtedly come to the commission at some point, in some fashion.
Okay. And then attached to your response to the bench request is a document called Fundamental Principles of Planning. Can you tell us why that's there and how it's important to this conversation?
So that document is basic our fundamental planning philosophy for our distribution system. It's out of our distribution planning document, and basically just kind of explains the philosophy that we use to explain that we base our distribution expansion planning on. So it really doesn't take into account grid modernization. It's just more of a traditional distribution planning tool.
Okay, and my reading of the elements of it really kind of tells me that overall the EPE system is looking at upgrades to kind of bring things to a modern operational level throughout your system. Is that a fair characterization of kind of like how all these elements fit together?
I think that's a fair assessment, yes.
Okay. And I had a last question, and it's about the response to the bench request about the proposals for federal funding. And like our other utilities, EPE didn't do very well in the first round and were kind of turned down for just about everything you asked for. In PNM's case, the rationale was, well, none of this is cutting edge, right? People have already done this somewhere else, right? So is that the response that you got from DOE, EPA, or whoever else is giving out the money, and how have you responded to that?
So yeah, some of our applications have been based on that it wasn't cutting edge enough. A lot of it was either, well, in like one application, we partnered with New Mexico State University to look at a virtual power plant. We felt that addressed our cutting edge, lack in some of our other applications. But in that one, they questioned our ability to be able to execute it since it was so cutting edge. So
damned if you do, damned if you don't.
Just can't win, right?
Trying.
Yeah. So, we're working on trying to strengthen our applications going forward, but that is a challenge.
Thank you very much.
Thank you, guys.
Great.
Thank you.
Thank you very much, El Paso Electric. Appreciate your presentation and attendance. Appreciate it. Now let's move on to public comment. Do we have anyone in the room who'd like to make a public comment? And here we're gonna limit remarks to 3 minutes per person. Looks like we have no one in the room. Mr. Rodriguez, do we have some folks wishing to comment on Zoom?
Yes, Commissioner, we have 2 individuals signed up.
Okay, I'd ask you to please keep a clock, Mr. Rodriguez, and limit comments to 3 minutes. Please go ahead.
Okay, Andrew, go ahead.
Thank you. Good afternoon, commissioners. I'm Andrew Stone of the New Mexico People's Energy Cooperative, which works for a speedy and equitable energy transition. First, thank you, Mr. Price, for the informative presentation today. I was pleased to see there is a value assigned to saving land by building out customer-owned solar compared to utility-scale solar. However, the amount of behind-the-meter solar in PNM's 25-year projection seemed small compared to what NREL and others have specified as the least cost future grid by citing DERs meeting 30% of total future load. Given the extended length of time for T&D upgrades, including long procurement times for equipment and NIMBYism, I would like to inquire how the Commission will be addressing FERC 2222 by developing tariffs for behind-the-meter virtual power plants, VPPs. More distributed battery storage on the grid allows for more behind-the-meter solar to be interconnected and to store this clean energy for use during the evening peak. Google, NREL, and others have declared that VPPs represent the fastest and most equitable way to create a resilient modern grid. Equitable because homeowners and businesses can participate in these networks, such as Green Mountain Power has done in Vermont with their Bring Your Own Battery or Buy One on Your Bill program. Now, PNM has demonstrated leadership in these wire alternatives with their DOE grant applications for VPPs and ADMSs, and in projects at Kirtland Air Force Base and Mesa del Sol in conjunction with Block Energy to provide their own ratepayer-based VPPs. But we also need a way for ratepayers to monetize their battery storage. As we anticipate huge load growth from AI, server farms, EVs, and home electrification, VPPs can solve several problems, including delaying transmission and distribution upgrades with their long lead times and expense, allow ratepayers to interconnect their own solar on distribution circuits that are closed currently due to overproduction of solar, and perform the peak shaving and grid stabilization by having these network batteries be utility dispatchable. Please consider developing pilot programs that allow ratepayers to either bring their own battery and, if income qualified, receive a battery via grant to meet the equity goals of grid modernization, and perhaps allow the pay-as-you-save model, which is the on-bill purchase of the batteries that will be dispatched by the utilities. Thank you for your time.
Thank you for your comment.
Okay, next, Michael Kenny.
Hi, yes, can you hear me okay?
Yes, go ahead, Michael.
Yes.
Yeah, so I just wanted to say a thank you to the commissioners and to the utilities and to E3 for putting this all together. Western Resource Advocates has been involved in, I think, many of these processes in the past, and I think we look forward to continue doing that moving forward. The distribution system is fundamental to all of our climate goals, to our energy efficiency goals. And the more we can work together to understand how it may be a bottleneck or what opportunities exist to make it more efficient, more effective, we're very supportive of and look forward to engaging with you all on. And in particular, looking at how non-wires alternatives can be implemented more effectively and with more, I guess, engagement from stakeholders. I was very happy to hear that there's a lot of kind of distribution system planning already underway across the different utilities at different scales. And so the more we can kind of streamline that effort and engage folks in that planning process, I think we'll end at the end of the day, get a better outcome for all New Mexicans and be able to reach our climate goals more efficiently and effectively. So I just wanted to thank everyone again and appreciate this opportunity and look forward to continuing the conversation. Thank you.
Thank you, Mr. Kinney, for your comments. If there are no other members of the public wishing to make comment, our next item is concluding remarks. Commissioners, would you like to say anything in closing?
Yeah, I'd just like to express appreciation for Mr. Price. That was very informative, and everybody else that participated today. So thank you.
Same. Thank you, Mr. Price. I also found your presentation to be very informative, and the comments from the utilities as well. It's given me a lot to think about. I'm certainly interested in hearing more about in the record about when it's appropriate to have a least cost, best fit approach and benefit cost analysis. I think, I heard some persuasive arguments as to why sort of a hybrid approach is more appropriate. And so, yeah, I'd look forward to hearing that. And so thank you all for participating and coming.
I'd certainly like to echo those sentiments. Thank you so much to Mr. Price for coming in and making an excellent presentation. And thank you to the utilities for being here and engaging on this topic. I personally believe that a rulemaking on grid modernization and distribution planning should be a high priority of ours. The legislature did pass statute in 2020 on grid modernization. We have yet to pass a rulemaking on that, and I believe that's a shortcoming that we need to work to address as soon as possible. Yet we shouldn't just pass something so that we can say we've passed it. We really do want to think through the best approach to grid modernization and how we're going to be evaluating these applications, whether they ought to be in the larger context of planning, how they fit into distribution planning in general. So I view it as very valuable, these series of workshops and conversations leading up to that that rulemaking. In terms of next steps, you know, I think what we'd like to do next is have another workshop that would focus on the question of transportation electrification and how that fits into distribution planning. Our current situation, as you all well know, is that we have a statute that requires transportation electrification plans be submitted. But those typically have dealt with things like rebates for installing charging infrastructure. They haven't dealt with what changes need to happen to the distribution system in order to accommodate the kind of growth in EVs that, you know, Mr. Price was referring to, that is most likely coming down the pike. And so everyone's schedule looks pretty busy in the near term. So I think we're looking at early July to have that conversation. And similarly to this, we would get the help of Lawrence Berkeley in getting a couple of speakers to talk about how these issues around EVs and distribution planning has been addressed in some other jurisdictions. So I think we haven't internally discussed, we don't have a time frame as of yet for this grid mod rulemaking, but you know, my opinion is that we should proceed as quickly as possible, but not too quickly. So I think we'll be getting in touch soon with a specific date for that that July workshop. Again, thank you to everyone for your participation. I would just quickly mention, as I'm sure you all know, we have a 1 o'clock public comment session dealing with our reliability rulemaking. So we'll probably see you again soon. Thank you so much. And if there are no objections, then this meeting